check. Usually the check will come in. I'm not that worried about getting a check. The only thing I have is you have to have a minimum state of awareness for like $10 or $15 to get a check because they have
So that's good to know, though. So you want to that makes it.
That's why I created a file and take a couple boxes of totes, buckets for the stuff.
What about those car batteries?
Lead.
Take batteries, like car batteries. I think you get but they will take them. They will pay you probably 3 cents a pound, but they will recycle. A lot of the steel stuff ends up being crushed and goes to Smiths or steel.
Yeah.
A lot of the other components like the copper, the aluminum, probably goes there too. So much circuit board. They have other people.
Good morning. Those of you who are interested in our ongoing series on restoration of All-American 5, can I have you come into the forward seat so I don't have to yell quite so loud? And I would invite folks to grab a handout. This particular one, this is actually a redo of a presentation that we did in April, in fall of 2019. I am told by many that they still have this booklet on their bench as a reference. So this would be a good one to have. If you've already got one, I invite you to take another if there are enough and pass it on to somebody who doesn't have one. Because this does cover coloring codes for capacitors, resistors, and speakers and transformers. There's a little guide to have. So I'll start those passing around and see if I can have the leftovers. Always somebody who calls me and said I missed it when I get the book. So this morning we're going to talk about components. This is the second in the series. For those of you that were not here last time, we talked about safety and safety devices. Today we're going to talk a little bit about the components that we use. Today is not a theory class. This is more of an identification class. And we will follow on with a couple of classes on what I consider preferred or necessary test equipment to do radio restoration. We're not going to get into the oscilloscope right away. We're not going to get into arbitrary function generators. We're not going to get into phase arrays or things that you might find on my bench or George's bench or Sonny's bench. We're going to get into stuff that you need to do radio repair, kind of as a minimalist, but we will cover 99% of your needs with just a handful of inexpensive test equipment. We will follow that with a little bit more theory on components. And I'm going to invite some resident experts to assist us in that. In fact, I may step down for a few meetings and let some folks talk about components. I would seriously make sure that you're here for those. Those people are hard to find in any group, let alone once you walk out of this building. And after that, then we're going to start in with the actual radio. We'll understand the components and how to identify them. We'll understand how to use our test equipment. We'll understand how to do it safely. And at that point, we can start learning about what the radio does, each individual piece at a time. The All-American 5 demonstrator that you saw a couple of months ago up here, it will start making regular attendance as well. And we'll actually use that demonstrator, and there'll be opportunities for you to get up out of your chair, walk up, and take a look, both during the presentation and after. And you'll be able to bring your schematics. And if I know about them ahead of time, we can actually bring them up on the screen and talk about any interesting things you found. And when we're done with this series, sometime down the line, I think everybody will walk away with some really good experience, far more than we ever intended to share with you. And that's because at the end of this, it will be more of a sharing of understanding and not just two people up here, blabbing away. So I have a presentation that we used last time. Apologize, we don't have curtains on the windows and we can't black it out in here, but we'll do the best we can. I'm going to move this forward a little bit. It's going to make it smaller, but hopefully a little bit brighter. That helps a bunch. Thank you. Let's see if we can. There we go. That's a little bit clearer. So again, today the Tech Talk is on color codes and vintage radios. There are other color codes out there, I'm sure, but we're only gonna talk about you. Pardon?
This is excellent.
Thank you. I only claim to be plagiarizing with many good sources. We're gonna talk a minute or two about math. I don't like to get heavy into math. That is an engineer's thing. But, and I already see the look on Sonny's face. It says he's gotta know a little bit of math to do this. And we're gonna cover a little bit of math. Just enough to make you dangerous and enough for you to pick up the phone and go, Blake. Mike?
Yeah.
I don't remember how to do this. That's okay. The book
One
will help
plus
you do it.
one.
We're gonna talk about color codes and mnemonic. How many of you know the ever famed, much maligned Navy version of the resistor code? Starts out, how does it start out? Bad boys do something they shouldn't do. Okay. And by the time we get to the end of the mnemonic, you know, so we're gonna talk about those and some more tasteful ones. Sorry.
I'm glad you cleaned that up.
Yes. In fact, I think the Navy one isn't even in there. I was too afraid to put it in. Besides that, everybody knew it. We're going to talk about capacitors, a little bit of the historical information. We're going to talk about capacitor color codes. And those are the worst because you've got one for mica and you've got one for the newer capacitors. You've got three
different major.
Yeah, major ones. And let's just for fun note that all of the stuff that you guys are pulling in from China now, shame on you, buy the stuff from you, stuff from China. They have numbers on them, or they're rated in nanofarads, or something else that's difficult to read.
Color code isn't very.
Yeah, and the resistors and the others. I have some new 3-watt resistors.
Yeah.
I'll tell you what, I really struggled with them, and we'll talk about it in resistors because they've decided to invent a new color code for themselves.
Yeah, they did.
And then we'll talk about examples of modern codes and some other color codes. So without further ado, let's get started. Component mathematics. I'm going to let Mike talk to this one because you want to talk to this one?
Which was what now the, oh.
Oh.
No, I read that and no, go ahead.
Okay. In the electronics world, we work in powers of 3. Okay. Just like George held up a minute ago, powers of 3. Not only do we have 3 major codes for capacitors, but we work in powers of 3. 10 to the third is 1,000. Okay. 3 and K. If it's 10 to the third, it's a K or a kilo. 10 to the 6th is mega, and we see that in megahertz. We see the K in kilohertz. We also see it in kilo ohms. We do not see megafarads. That would come in a building. Okay. So 10 to the third, 10 to the 6th, those are the big ones we use, getting bigger. So 1,000, million. We also use, going backwards, 10 to the -3, 10 to the -6 are very common. 10 to the -9 is starting to make an appearance on the horizon, but for the most part, it's -3, -6, and -12. -3 is 3 decimal places to the right of the decimal, to the right of the decimal point, 3 places. 6 is 6. Or we can replace these with values like microfarad, okay, or picofarad. Microfarad is 10 to the -6, and picofarad is -10 to the -10 to the -12. That's as deep as we're going today. To convert, for instance, you want to go from picofarads to microfarad, you're going 6 places, and you're going less negative. You're going from -12. Remember the old numbering scheme where, you know, -12 was out here and -3 was here? You're becoming less negative. So you move the decimal point to the left, getting bigger. So a lot of times you'll get into a radio and the radio will have a value like, let's say 0.00047, or in a zenith, very popular value that you don't see in a lot of other radios, 0.0005. You may go through your capacitors and go, wow, they stop at 0.001. I need another 0 in there. How do I get to something I can use? Well, you can move 6 places to the left, and suddenly you get a number that's whole. You might come up with a number like 470 picofarad. You go, oh yeah, I've got a box of these mica capacitors. I remember learning that those are mostly picofarad. And you go digging through and you find this capacitor or this resistor, and you find this capacitor that has some dots on it. You figure out that, hey, this is a 470, or hey, this is a 500. Well, what is that? Well, if you do the math on it and move the decimal back, you'll find out that 0.0005 turns out to be 500 picofarad. And that's when you need the power of this. How many of you have seen the little cards? Some of them, most of them are about this big. They got 3 little wheels on them with little color wheels, and you can dial it up and it'll tell you what the number of the capacitor is.
Yep.
Most of those, for those of you who have never turned it over and looked at the backside, it'll also do capacitors. Those little pieces are fun. They're still readily available from Elenco, still makes them. I have a collection of about 40 of them that go well back into the 30s. I've even got a round one. I wouldn't recommend it for anybody to use. It's really difficult. But the ones with 3 wheels on them, they're square, got little windows in them. The nicest ones I've got were from Sylvania. They've actually got little cogged wheels that you can crawl with your fingernails, where they're easier than just the regular paper discs. If you see one of those, grab it. If it's really unique, bring it to me and I'll give you an Elenco. I collect them. All right. Questions on the map. This is the most difficult slide in the whole thing. Just remember, we move them in groups of 3. You really didn't want to do that one?
No, I don't care. I would have been that. That's fine.
Okay. Well, why don't you do it? See it now.
Yeah.
All right, Mike, I'm going to let you do the mnemonic one. You want to do that one?
Yeah. This here you mean you're talking about?
No, slide.
Oh, okay, on the slide. That's fine. After a while, yeah, you can do this too. Like this is the what he's talking about as the Navy, the big boys race our young girls. But Virginia, that's been cleaned up, yeah.
You think?
But quite a bit. When I first started doing this, I had to go through, and in fact, I had a little programmer app on my phone so I could look up and see what all of the color codes were on resistors so that I would know what they were. And in having worked on a lot of, several radios, after a while, that over time, you start to have that ingrained in your head, to where you know that as far as the first 2 digits on the resistor, in this case, are going to be the numeric value, and then the third one is going to be the multiplier. And so then you always kind of have an idea of how that works and get that through your head. But it starts out with black is 0, and of course brown is 1, and then red's 2, and then what is it?
3 is orange.
3 is orange. Yeah, I'm trying to. And then 3 is orange, yellow is 4, red is green, and then 5 is green, and then 6 is blue, 7 is violet, 8 is gray, and then 9 is white. And so then you kind of get to where you know what that is, and then
What's 10?
That's the black. That's the brown and the black.
Yeah, good. Oh.
But anyway, and then the multiplier is going to be whatever that happens to be times that. So, for instance, you take a 2 is red, and then you times that times, like, let's say a yellow. Okay, or you could do orange, which is 1,000. So that's 22,000. Or 22K, yeah. And then you get into stuff like when you get into mega ohms, you have to kind of watch out because, for instance, if you want a 2.2 meg ohm resistor, those are fairly common. Then it'll be red times what?
Green.
It'll be green, exactly. But if you want like a 15 meg, then it'll be brown, green, and then it'll be blue. So, because the blue is actually times meg or 1 million. So anyway, and you just go right on down the line, and then it's a fairly common system to use to be able to figure out. And then down here below, you have your tolerance, and that is like in the gold is a 5% and 10% for the silver. But if you have the book in there and you're new at this, if you turn to the page, it'll tell you what all of the different colors are. And then and it should also show you what the, when you get into this, it'll show you what the multipliers are. And you can figure out, here it is, that's what I'm looking for.
Is
And then
there
you
a,
can figure out what all your resistors values are if you're not used to using the system.
is there a 1% indicator?
No.
No,
At 2,
Percentages are always stamped.
yeah, at 2% or 1%, they generally stamp right on the basket.
oh, okay, that's good.
I've had a lot of, brown stripes on the end.
Maybe in the modern ones.
So any questions on that?
The old carbon
Jeff.
resistors that have no tolerance band or
Oh,
20%.
yeah. Yeah, you mean like these here? Let's cover that a little bit.
Allen Bradley.
Well, these are what they call the dog bone resistors.
Or the Allen Bradley.
There's Allen Bradley, yeah, that's right, thanks.
1950 style.
These are more like 30s.
30s.
Yep.
Yeah, you'll see
Real-
these in the old Philcos and stuff like that. It's the same system, except you use body, end, and dot.
What do you guys sleep in at night?
A bed.
Bed.
A bed. Keep that in mind.
Yeah,
with the
body,
dog
end,
bones.
dot.
I'm gonna pass some dog bones around, take a look at them. You might even be able to figure out why they're called dog bones.
Yeah,
That's because if you drop them on the floor.
the one on top here, this is brown, orange, and orange. So that'd be 1, 3, that'd be 13K. And that's just, it's just as simple using one of these as it is.
I would advocate for
carbon.
those of you who are really interested in, when I started working on radios, these things drove me nuts. It's easy enough to get the value, but so it's hard to figure out, well, what wattage are they? Because, the 1 watt ones are pretty good size. I mean, they're this big. I have 5 watt, the modern resistor size. So we meet a bunch of these things up. Come up and take a picture of this with your smartphone.
Yeah,
Put your finger next to it or something so you can judge the size. This is handy, and I've run out of. I can't make any more of those.
you'll have to save them up when you do a Philco or
Yeah.
something, yeah. And so that's how that part of resistor color coding works anyway. So any other questions for George?
I've got a challenge for you.
Oh,
I
boy.
have a German radio,
Yeah,
and every part is painted red, whether it's a capacitor or a resistor. It's all red inside.
really?
Would you like to tell me what the values are?
I will if you give me.
You
a
can give me a
schematic.
schematic.
Well, I don't have that.
Well, that'd be the first step.
Does it work?
I actually have a Nord Pende on my bench right now. and About half of them are red, and the rest of them are brown, and you're right. And of course, most of
Yeah.
the brown ones have values written right on them. The red ones do not.
You sure it didn't come from Red China?
Ed,
I'm positive, no Chairman Mao stamped on either one of them.
yeah,
that kind of have their own color scheme for this stuff.
Early, yes.
oh, okay.
And none of this makes any sense when you're working on an old Atwater.
Oh,
Yes.
wow, that's interesting.
You've got to have the Atwater Kent book to do it. But fortunately, Atwater Kent didn't make any All-American 5 that we're looking at here.
Right.
But yes, absolutely. What value is a purple resistor? So
Oh, my, that's interesting. That's nice to know.
that's when you call myself or Mike. We've got the Atwater Kent books. I know George has
Oh,
them too.
really? There's a book
But
on
there's
our color
actually,
codes there?
Oh, yeah.
a book from Atwater Kent
Ah,
on how to identify the parts.
Call Cliff Tuttle.
yeah, good to know.
Yeah, he'd have it.
George?
The, I did find out why all the parts were painted red.
Yeah,
The radio was made during the war,
oh,
and they didn't want anyone else to know what the circuitry was.
oh, like the People's Radio or something.
Yeah,
Yeah. Does it have a variable capacitor or is it just one single station?
It has a variable capacitor.
Yeah.
Three,
Some of
three
those-
sections.
Some of those, they made, were not tunable. You just got their one
Yeah, the people's.
Oh.
people's radio.
Oh, that was
One,
the
one is
300
working
change
on the early to late fifties.
propaganda channel.
Maybe the end of, or after the war, when they start going back to, yeah. Goebbels didn't want anybody listening to any other stations, so.
Neither does Putin.
I noticed that Radio Free Europe has not come back on the air, nor has the Woodpecker, for those of you who remember that.
Oh, yeah.
No.
So-
But Google has. Google is getting into Russia with all the pictures.
Oh, good.
If anybody here would like to go to their computer and see something interesting, go to Weird History. Type in Weird History, and there's hundreds, all about the war, all about, it even gets into electronics and what the Chinese are doing, making capacitors. Amazing.
Good and interesting. Do that after you're done with your American Five for the evening. All right, so we've talked a little bit about dog bones. There is in your book a place to look up the DED or body and dot type of units. And I passed a few of them around here, and again, advocate that you come up and get a picture of this piece that Mike has. You'll be glad you have this in your record.
Yeah. Nothing else, just for the wattage.
This is the kind of thing you take a picture of it and then put it on the back of a cupboard door someplace. Okay. All right. There are three standards: American War Standards, body and dot. There's RMA, Radio Manufacturers Association, which added a third and fourth bands. And there's IRC, which is kind of the ones you're going to see in your All-American 5, the standard brown with the three stripes on them, possibly a fourth one for tolerance, gold being 5%, silver being 10, and no band meaning 20%. Remember that when you're checking the resistors. I've had people say, you know, he says, I checked the resistor and it was supposed to be a 220,000 ohm. It was 224,000, 4,000 ohms. This thing's got to be bad. No, it's all based on a percentage. My methodology, if you're going through a radio, just because I like to keep it simple, I use 10%. Unless it's marked gold, and then I adhere to that. But I look at the capacitor, it's 220,000 ohms. I know I've got a tolerance of 22,000 ohms either way. And if it's within those, it's fine. When it gets beyond that, I tend to replace them because that means they're aging and starting to age out. I really, my moniker for repairing your radio is I'd love to see you again, but not with the same radio. So if we can get it fixed right the first time, it won't come back. So I think about 1%, especially if you're just now starting to work on it. When you apply voltage and the radio breaks itself in a little bit, those are going to move. They're not going to move the direction you want, I guarantee you. One other thing I will mention is if you're buying resistors, a couple of things to be aware of. Avoid the ones that come on a blue body. This is a personal opinion of mine, and you may not share it with me, but the blue ones, they are blue, and then the stripes are put on over the top. The yellow bands tend to turn green. The blue ones tend to turn purple. They get very difficult to read. So if you have a choice between the tan colored ones or the blue ones, spend the $2 more on Amazon and go with the brown ones. They're easier to read. Also, they're now coming out with a new standard to read them, and it is a 4-band standard, which is first, second, and third digit plus multiplier. Boy, that threw me for a loop. Red, red, brown. Oh, red, red, brown. Oh, red, red, brown, orange. Or red, red, black, orange. That's probably more like it. You know, red, red, black, orange. I'm looking at that and I'm thinking 22 ohms. Red for 2, red for 2, black for 0. No multiplier, so it would be 22 ohms. No, it's not. It's red for 2, red for 2, black for 0.
220.
K, orange for K.
K.
So it is a 220 K. If you see that, if you see 4 bands of color on a brand new resistor, it's time to get out your own meter and make darn sure. Okay, I had a set of those that I won't say where they came from, but they were a gift and they were blue and I couldn't read the damn things. And they had this 4-color code on them. And after making a couple of mistakes and radio's not coming up, and when you put a 22 ohm resistor in where you need some 220 and it's in the high voltage side, bad things happen. You let the smoke out of these blue resistors real fast. I actually took all of them, put them in a bag and threw them in the garbage.
Is it one particular brand that made those?
No, I've seen them coming out of China, both on eBay and I even bought some from an electronics store and especially on Amazon, Fox the ones on Amazon, the brown ones. But the ones I bought them, and these were all 2 watt. I bought a 2 watt kit. And I thought, gee, 360 resistors for $7.99. Who could go wrong? Well, they went to garbage and I spent $11.99 and bought the brown ones. But then the problems, I can read them and I make fewer mistakes using the brown ones. So just experience that I'm passing on is be kind of cautious when you do that. George?
Yeah, why the difference, the cost between blue body and brown body from any company when they're supposedly the same value?
You'd think. I will tell you that the brown ones I bought came out of Taiwan. And the blue ones came out of China. I would not have bought them had they been in China, but again, they were a gift. I won't say that there aren't products in our world, high voltage capacitors and resistors that come out of China that are there may be some that are good. I have not found a reliable source from there. I tend to do either modern surplus or Taiwan or Japan if I can get them there in surplus. I avoid China, but that doesn't mean that someday they won't have a good product. I'm not going to malign them, but so far what I've come up with has not been terribly
You
good.
will go on what I just said about the History Channel, strange history. I want to type in modern China
Okay.
and you'll know why they're blue.
Okay.
Okay.
That may actually get me out there. I am kind of interested in why they're blue. And I know when I put one in the radio and it blows up, I'm kind of blue. Okay, especially when I look back and I put 3 of those blue ones in.
Are these dog bones are wire wound?
No, typically they are not. They are typically a carbon rod with a wire wrapped around them
Okay.
and squeezed and then
Are
painted.
they any more reliable than the old carbon composition?
No,
About the same?
no, yeah.
About the
I have
same.
found, I've been through radios where every dog bone in the radio has been good. And I've been through them when every one of them is on its way out.
Well, isn't it when it's on its way out is the diode, it's like a diode forming underneath the lead at one end.
Yes.
And all you have to do is heat that up and generally they come right back to normal.
Very often that's the case, but I'm far too lazy to do that. I've got I have thousands of good carbon comp and carbon film that I can put in there. All right, and if it went bad once, it'll go bad again. Personal
This is
opinion. All right, let me go ahead and advance this one.
I had a quick question, Blake.
Uh-huh.
For example, I had an old Silvertone and looking underneath, it had, I think it was green, that kind of looked like a fire hydrant, kind of style to it, but it looked green.
Mhm.
Are those resistors?
I would have to see them. I've not seen green resistors per se, but I've seen a lot of green capacitors.
Yeah.
Oh, okay, so that's
They're the small dog bones.
Oh, the little tiny
Well, the
ones,
little tiny ones, the little
Yeah.
capacitors.
so quarter watt.
Yeah.
Eighth
And
watt.
they're green.
okay.
And they
Okay.
can be green.
They were
Yes,
round like it
yes,
looked like a
yes,
spatula or lead off each end.
yes.
And they were either green or other colors, silver.
Yeah, what George is saying, the little 8-watt ones are very often green.
Yeah.
Okay.
Oh, okay.
Again,
Yeah.
you will not find these in All-American 5s, we're just too far down the road.
Yep.
Unless you have what I call a cigar box respiration. And that's somebody who has a cigar box full of components and they're using those components and putting them in the radio. And I've seen radios work marvelously after that. I've seen some that were not so marvelous. George?
There's one little thing that I've lived by, when in doubt, measure.
What?
When in doubt,
That takes all the
measure.
That takes all the fun out of it. Yes, that's a good point. When in doubt, that's why we have test equipment. Make sure you're here next time for that.
Yeah.
So again, on the resistors, just as a quick review, you've got typically 3 bands and possibly a fourth. First band, second band, direct numbers. Third is the multiplier. Add that number of zeros. And the last one, if it's gold or if it's silver, that'll give you the tolerance. There is one case, you will likely not see this in an All-American 5, but I will mention it, that the third band, this one that is colored green over here for the multiplier, there are some that have a gold or a silver band there. If you find the third band is of a silver or gold, you're looking at a resistor that is less than 10 ohms. It actually becomes a divider, not a multiplier. Okay. So, Joe, any of you have a resistor collection at home? Go pull an 8 ohm resistor and see what the color code is.
I've seen that before and I was like, what the heck's going
Yeah.
on here? Why is there, what does silver and gold mean?
So that you can get down under 10 ohms. All right, condensers. Condensers are the fun part. Love these things. When in doubt, replace them. That's my motto. So we've got a number of different kind of caps. The really fun ones. There are several different types. We're going to talk about mica first. There is coverage of these in your book. There are a couple of different standards. There are 3 standards and 2 sets of numbers. There's basic 3-dot mica, there's RMA 6-dot, and there's ANS 6-dot. Most of the coated capacitors in this range, the little brown block ones, are in picofarads. So you read the numbers in picofarads. When you are reading the numbered cap, 473K, it's yellow, got a lead out of each end. Okay, 473 means 47,000 something. It's picofarad. And then you can change it by moving the decimal point. See slide 2. Okay. The example here that we're showing, this is a Solar, this is an Aerovox, a Cornell Dublier. They're all kind of in the same boat. You will see a couple of these in your radios, and they will have color codes on them. And fortunately for us, the color codes have tended to hold up over the years. And so this one here has a green, a black, and a red. The example on this one, it is red in the direction of the arrow. Okay, green, black, red is going to be a 5, a 0, and red is 2, so it's 2 zeros. If you had a number associated, it would be the same number. 502 is not a common standardized number today. We would use a 473 instead of a, I'm sorry, we use a 472 instead of a 502. So again, green is 5, black is 0, multiplier is 2, 2 zeros. So this is a 5,000 picofarad, okay? And if you want to convert that back, 5,000 picofarad will come back as 0.005. Right? I need to move it 6 places to the left. 1, 2, 3, 4. 2 zeros in front of it, 5, 6, and a decimal point, 0.005. Right? I don't tend, at this point in my career, even as an engineer, the math doesn't really do much to me. I say 5,000, and I think in my mind, just moving the decimal place. I don't go, oh, this is 10 to the, let's see this. That's 5 times 10 to the third, and I want to get to 10 to the minus 12. And that's 10 to the minus. I don't. I move the decimal places 6 places to the left and call it good. Yes, and I tend to be a fairly visual person. For those of you who are engineers, understand that's an oddity, but so be it. Okay, RMA 6-dot. Okay, here we start up at the top. We've got the first digit, the second digit, and the third digit. Okay. Then we've got on the bottom the DC voltage, the tolerance, and the number of zeros. And you've got a piece over here that gives you the same layout. You have this in your book.
Temperature.
Pardon? There is no temperature in the RMA 6 dot that I'm aware of. I think you're taking of the AWS.
I got a whole bunch of them have an extra dot for the temperature.
Okay. I don't cover those in here. You will likely not see these in an All-American 5. But George says there's a temperature coefficient with some of them, so.
I apologize, they're military.
Okay, no, I don't cover the military in here, sorry. Although with the military surplus that has been available, especially now on the pre-table, I probably should, probably will enhance this to include those. There's also the AWS 6 dot. And you can see the layout on those. I have a Cornell Dublier, and this is in your book as well. Okay.
Right.
So you read this one in this direction, first with dots and then this way. What's different is that the previous slide, you did these and then these. Here it comes around, number of zeros of tolerance in the other spectrum that direction. I believe this is where you would find a temperature coefficient. Okay.
Hey, like, why is the first one always black? What does that mean?
I think that identifies it as AWS versus the RMA. So that's a good point. First one's always black. That identifies this as being an AWS 6 dot type. And so it
Well, it says on that
doesn't-
label, Joint Army Navy Standard. So is that like a military mark?
Yeah, Jan is,
Jan is
Oh,
military.
yeah, joint, okay.
same thing with two,
Right.
Mark Jan is two, military.
So this is AWS. Again, look for the first dot. You would never start a value with a 0. And that's kind of the giveaway, and that's why they used black. If they had chosen brown, well, then we'd have a hard time discerning, is this AWS or is the first digit a 1? So black is the first dot. Okay? I've got a bunch of these at home. They're brown, they're a little bit bigger. They're not quite as long as the others. They're just a little bit more square, but they're not perfectly square. So again, this is covered in your book, but look for the black dot. So these 3 pages we just gave you allow you to pick up a box of micas off of the back table and go home and sort them. And you know, they're weird because they seldom go bad, very seldom. But when they do, you never have to write that. So I kind of encourage people to take, you know, I've got my micas. I have, if any of you have been over to my house, Ed, you can tell them. I keep my capacitors in about a 12-foot wide bag full of those large plastic tubs. And those plastic pieces have thousands of capacitors each. You need a 0.047 at 600. There's probably, I don't know, 400 or 500 of them in the bin and 3,000 storage units back that up. When it comes to micas, I keep them in plastic containers, and if I need 100 picofarad, I'm probably going to have 20 in the box. But if I need a 152, there's likely only 1 or 2 in the box. I don't need a lot of them. They don't go bad, but when you do need them, it's nice to have them. If you get stuck and don't, only always happy to help you get your radio bill. But they will seldom fail when you're restoring your All-American 5s. I would not take them out of the radio and replace them just because. We have paper caps that are embellished to look otherwise that we need to replace, and electrolytics will replace.
And don't be surprised if you see the microcapacitors over an inch long and less than a quarter of an inch wide. And they're about like your thumb, the length of your thumb. And you don't see them anymore, but in a lot of the older radios that some of us worked on, that's where you find them. And I've never found a bad one.
I haven't either, but I will say regarding that is if you come across a mica mold one that's a quarter of an inch high and an inch and a half long, beware. That's liable to be a wire wound resistor.
Yeah. You took, yeah.
And the other thing I will mention while we're on the subject of older radios, if you've got a Zenith radio and many others of the mid 30s to later 30s era, and you look on the schematic and you see all of these caps of 22M and 33M and 47M.
Oh, yeah.
Tell them what that is, Mike.
that means K, not meg. If there is a mega ohm resistor in the schematic, it'll be spelled out MEG. That's how you tell the difference. And this is on stuff from like the 30s, and that was before that meant millennium is what they were coding that with the M, instead of using the K like what we're used to. So beware of that. There was one fellow that wanted to know where he could come up with an 87 mega ohm resistor, because that's what was in his schematic, or 86, whatever it was. And we had to point out that that was mega ohms. It was millennium or K. So kind of beware on the older schematics. And then another one I wanted to mention, I ran into, and it was on an older General Electric, and it had two capacitors that were line safety caps, and they were both going to the chassis from each side of the line. And they were big ones like this, and they had the regular mica plastic on them. And what they were not mica capacitors. They were paper capacitors with plastic mica around them, just to fake you out. And the fun part about that is I had one of them that blew and it shorted. So now I had a transformer hot chassis. It was running right off the line and taking the line voltage on one side and going right to the chassis. And so, yeah, that could have been an ouch. Luckily, I didn't get shocked on that, but I found it. And then I found out what happened. And then, of course, obviously replaced both those line caps. Sonny?
I want to make a comment on the mica mold too. Anytime you see mica mold brand on what looks like a mica capacitor, it's either a resistor or a regular paper capacitor stuffed in one of those, and they're always bad. If they're capacitor.
Is that it? So the brand is mica mold.
Yeah.
Okay, great. All right. So beware of that.
The mica mold, yes. If it's branded mica mold, they're always bad.
Yeah.
I've never seen a good one.
Oh, good. Good. Ed?
Well, your ohm meter will help you considerably if you have in doubt about whether it's wire wound inside or it's a shorted.
Right. Ed?
I just recently watched a video on restoration, and the gentleman referred to safety capacitor
Mhm.
being used in a line filter surrounding
Yeah.
power line. What is a safety?
Well,
It's a fuse.
that's supposed to be made as a fuse. In other words, instead of using a regular fuse, which I recommend, by the way, that's what I do on all my transformer sets. And instead of doing that, they would use these capacitors, and the idea is that if it overloaded the circuit like lightning, whatever, that wouldn't be on the power side. But if you had a power spike, in other words, on your line coming in, that they were supposed to fail open and just to act just like a fuse. And they also are used in that circuit to cut out some of the RF out of the line to take some of that out of there.
Right, but how do you recognize a safety?
They say X, Y.
They say X or XY on them. If you want to get a real line safety cap, you can purchase those. And they or X ones are where you have the capacitors that cross. They're called X, and that means cross. And that's where the two capacitors cross the line from one side to the other. And the Y are the ones that go and take from the line and go to chassis with them.
Okay.
Yeah. Sonny?
Back on how do you identify them? Usually they're just a common capacitor like the tiger stripe you show up
Right.
there. And they serve two purposes. One, as he mentioned, to block RF and going back in the power line. And the second one is if it shorts out, instead of having a hot chassis, you blow a fuse.
Yeah.
It's essentially wired across the power line.
Yeah, right.
So it also, because many of those chassis were hot, it goes from the hot side of the chassis to the other side. And so if it shorts out, it blows the fuse instead of the radio.
Right.
Or creates a hot chassis.
Right.
And one more comment on a safety cap. Back in the seventies, there was a safety capacitor used in television sets. And that was because some of those early color television sets, when the high voltage went up so high, it produced X radiation. So if your kid was sitting there 2 feet from the TV staring up at the television set, and the high voltage went too high, they were being X-rayed to the point where their eyes could be damaged. So they invented a safety capacitor to prevent the high voltage from ever getting above the specified level. And they call that a safety capacitor, but it was a totally different circuit than what we're talking about here in radio. But so if you hear of a television safety cap, it's not the same.
So, all right, any other questions? I guess the tubular plastic capacitors that we're taking a look at here, and they're just basically in
What do we call those?
Bumblebee.
Bumblebee or tiger, I call them tiger stripes. They're always bad.
yeah, they are.
Full stop will be bad.
Black caps are always bad.
But guitar amplifiers love them.
Right.
Never heard of
I
it.
just learned that some people actually make jewelry out of it. So my bad dual stock ones are gonna go with somebody today to be possibly turned into jewelry.
Now,
They're always leaky, but
the-
guitar people love them because they're used in the low voltage circuits. And the leakage actually improves the tone on certain guitars.
Leaky electronically, not physically.
Anyway, this here is the same example, only you use it in, turns it into 22,000 picofarads. Now, can somebody tell me what's wrong here?
This is a test.
Nothing wrong, but it's right.
No, what's wrong with the math, I guess?
I can't see it.
Oh, I think you have, one too many zeros. on
Yeah,
the final
You're
number.
right, exactly. It's actually a 0.022.
All right, I see some gold stars out there.
Anyway, we caught that, but it's no big deal. Now, the interesting part too, now you see on your modern yellow Mylar capacitors, they'll be, instead of putting the example of the rating of the capacitor written right on there. A lot of them used to do that. Now they have a coded number. Well, that coded number, it says right over here, it's the same thing as using the colored stripes. So in other words, for instance, if you had like a 473 written on there, that would be 4 and 7, 47, and then times the 3, which would be times same thing as here, times 1,000. So it'd be 47,000 puff. And then you do that, and that turns into a 473 is a 0.047. You see a lot of those. That's a
And also on that cap, the yellow is the voltage rating.
The yellow is the voltage rating.
Yep.
Okay,
Your money
Good
page,
point.
if you all look in your book, there is a.
Very good
chart
point. That's
in-
right.
and I think it's almost the last page. That will go between.
Stands for 400. but
400 volts. So that's right. That's right, Christian. So that's a 0.022 at 400 volts. It's got the yellow for the voltage rating. Very good. It was blue V600.
Before we look at other codes, the one thing I do want to mention is a lot of you are going to find electrolytics in your radios. Okay, these guys, a lot of you will have these guys, okay?
Sure.
Some of them will be brand new, some of them can be reformed. There's two ways you can tackle it. Somebody brought in a radio this morning. Are they still here? I think they left. They got a book, but they had taken just loose caps, I believe, like these, and they put a terminal strip in and very neatly cut the wires off real close to the capacitor and then took those wires over and terminated them on a barrier strip or terminal strip. Nice clean way to do it. But these are typically bad. And you'll know when you turn the radio on because it'll start off humming at you, and by the time it's done, it's howling at you with the same note. You can do that. Some folks, I really like these when the radio's got a clip in it. How many of your All-American 5s have a little spring clip inside that holds the cap? Anybody find that in their radio?
Yeah.
These are really nice because they pop in. These basically have, this one has a pair of 47 microfarad, 160 volts, a little bit higher voltage than the originals, but it was rolled around a regular one, caps are stuffed in, and then the unit is topped off with a, nice dose of hot glue. So it's not going to crush. It'll snap right in there and go. These are easy to make. A little bit of photo paper and a printer and a little bit of hot glue and some wire and caps. You can make something beautiful underneath that absolutely nobody will ever see, but you'll know it's in there. This is probably overkill for a lot of the work you're doing here. You see these. There used to be a company, I think, called Pioneer that used to make these, and I just personally had a problem paying $7 for 2 caps rolled up, something filled with plastic. So instead, I took 50-cent caps.
You spend $10 per time making $4 cap.
That's it. You know what? There are days when I come home from work from the great BPA that all I feel like doing is filling rolls with hot glue. And I will make these usually 25 or 30 at a time. I got a big Teflon sheet. It's just lined up and sit there with my glue sticks in one hand and done. But anyway, that's me. Pardon?
Yeah.
What's that?
I say, I don't believe you.
All right. Some of you will have these guys up on top of the chassis. These are more interesting to deal with. I typically like cut them open, gut them, and put new caps in them and put them back on the board. That really is a huge waste of time, but this is one of those stress relievers. And I will tell you how I've gotten them off. Is I try to get as much solder off of them because most of these are twist locks. They go in and they put a twist in them. Then they come back and solder wires to them. And oh, great! You got to get all of that off and straighten them out. You can do that. What I have found is you get as much of it off as you can. I use vice grips to straighten them. Then you got to get the little cleats down at the bottom. Get as close as you can. Grab the cleats. And then I will use a screwdriver on the top, heat it up, and then one leg at a time, I will pry it out. That's the easiest way to get them out.
That's only $20.
That's only $20 worth of time, but it's okay. I'm doing it on a Catalan radio. I'm selling it for $1,000 a ton.
I just cut the leads off and then put them on barrier strips. But you always want to leave the old cap sitting up there just for show.
Yeah, don't take it out.
Yeah, don't take it out.
Unless you're working on the Zenith and there's no place for caps. Yes, David.
I didn't quite understand that. So, what I did on one of those packs, cut the can, took it apart, and then I put the old pass out. Can grab through the miller.
Yep.
So how do you do that?
Well, you can do them one of two ways. You can leave them in the chassis. You can cut them. I take the capacitor out of the chassis.
Yeah.
And then do it. And my method of operation is I generally come down a little ways, only about that much, and I will make a cut, use a roto tool and cut all the way around it. I do that by laying this on the table and my roto tool and turning this and goggles on. And then when I put mine back together, heat shrink works really well, but the aluminum tape that you can buy at Home Depot for doing duct work up in your attic, one roll of that is enough for 5 people for 2 lifetimes. You can cut a little piece off of about that big and then cut it in half. And I'll literally, half is still, 1.5 inches wide. I will actually use that and form it back together. So when it goes back on, you can tell it's been rebuilt because it's got this foil around the edge, but it's a nice, neat way of doing it. And it's a lot cheaper than heat shrink, which requires the heat shrink this size plus a bunch of butane fuel or an expensive heat gun shrink. George?
Yeah, just a suggestion. If you go to Home Depot, you can buy this bottle of glue everything. It's blue. it's got a blue top.
Mhm.
And I found that if you, instead of putting the tape around, you just put a bead of that around and then you can't
Mhm.
tell.
Oh, good
Oh,
idea.
good deal.
Good deal. So there's another idea. You can use the glue. Sonny, you think you like find had some really cool glue you can put on there and then you can use an infrared light on it.
Kind of around there and then, and heat the big part up a little bit, and sometimes you pull it right out. Other times you gotta drill this stuff out.
Yeah, or
Oh, yeah.
use a heat gun. Very often, what I'll do is if these things get stuck, not so much this vintage, but the really older ones full of tar, I will actually use them, I've got an all metal corkscrew and I'll put them on the barbecue. I went to the barbecue just my wife objected for me using the oven. But heat them up and then take 5 minutes on the barbecue, get them heated up. Now we take that corkscrew, screw it in, up and out. Yes, sir.
Yeah, I kind of do the same thing, but instead of putting that metal tube back on,
Mhm.
discard it, and I have cardboard tubes that fit perfectly. And I
Oh,
use black,
nice.
flat, black spray paint.
Oh, that's awesome.
You know,
And
it
then what's
looks like
original?
original, and it's paper, so I don't have to worry about shorting out the leads of the new capacitor.
That's good. That is one thing I say, is when I do put capacitors in here, I do sleeve all the leads. I buy my 24 and 22 gauge fiberglass sleeving in 500-foot rolls.
Whenever
I
I
got
see
tired of
cardboard
the
tubes
roll
laying
that
around,
Yeah.
rolls up and take off.
no matter what diameter, I just
Yeah.
hoard them.
Grab 'em.
Cardboard's a good idea though.
Yeah.
And a lot of them had cardboard covers
Right.
on them. So you're right. They look
One
good.
other thing we didn't cover, and I just thought about it, maybe we should have brought some, is, on the older Philcos from the thirties, you see the Bakelite blocks. And, I like to, on those, I like to rebuild them. It just makes it for a cleaner restoration in the radio. You can, pull the leads off and then, put barrier strips, whatever, and tack around them. It's fine, but I like to rebuild them. And what I do is virtually just about like the same thing. I'll get and cut up on top where the connections are and cut the little wires off the capacitors inside. And then I will get a screw and mount the Bakelite block onto my vise. And then I take a drill and I'll drill right through that tar. And then I put a sheet metal screw that will drill right down in there. And it's even good if you can drill right into the old capacitor. Put a sheet metal screw in there, and then while it's in the vise, I take a heat gun and a pair of pliers, and I put a little pressure on that screw, and then I take the heat gun and go around the Bakelite block a little bit, till finally, pretty soon, that whole piece of tar comes out in one big chunk. And now you got a real nice, clean Bakelite, what's left of just the block, no tar in it. And then you can go ahead and put your new capacitors inside up through the holes and then solder them to the connections on top. And that's how I've always done it. It seems to work pretty good. Yeah, Pat?
If you do that, do you have to cut the lead off the top?
Yes, because what will happen is as you're pulling that out, it'll hang up. Those wires will hang up and they won't want to come all the way out. So that's why I always want to cut the leads, the little tiny wires up on top from the old capacitors. And it's easier to cut them because if you try and take them off with a solder gun, all of that tar starts to bubble up and come up through the holes and makes a mess. So I just use a pair of dikes and little tiny wire cutters, and I'll cut those things off, right there where the solder is, and get them cut off. Then you can just suck that tar right out of it.
You pour tar back in?
Nope.
Why?
Well, you can if you want.
Why?
Yeah. No, I
The
just put
radios
new
are already
capacitors.
heavy enough without.
Yeah, I
without
just put the
tar.
new capacitors in there, and if you do it right, one will usually be going from, say for instance, if they're bypass caps and they're going to ground, both of them, and one will be going in through the short holes. You put that there, and then you put that one in first, pull the leads up. Then the other one goes to the hole to the back of where the hole is furthest from the ground connection. And then you put a cap there, and the leads will never touch each other. You just pull them up tight in through those holes. And then you're never gonna have them short out against each other. They work just fine. So, you can put hot glue inside or whatever you want to do, but it isn't necessary. I just put the caps in and solder them up on top and then put them back in the radio.
Couple of things, and then we'll be wrapping up here. 3 things. One is I'm passing around some can capacitors which sit up on top. Does anybody know how to tell in a multi-section version of those, how to tell which one's which?
Yeah, you have different symbol codes, triangle, square.
Triangle,
And a half
circle, and a half circle. Those are the typical ones. Where are those located?
On the little phenolic on the base of the
And
can,
how are they identified? How do they do it?
etched in.
Sometimes they're etched in,
Prep.
sometimes they're cut out.
Oh,
If you
cut
look
out,
at-
yeah.
And I'm passing some examples around. Where the lead, if you're looking end on, right where the lead meets it, you may find that there's a piece of triangular phenolic missing, or a little square piece, or a little half moon. And if it's a 4-section, you'll have those 3 plus 1 that has nothing on it. But be careful when you look at those, because sometimes it's not obvious where they are. Zenith was real good. They like to put theirs on the outside of the lug, between the lug and the can. And then they slapped it on one of these and wired it up, and it was very difficult to see them if you get in with a
Some of them are
flashlight.
triangles.
Yes,
Yeah.
triangle,
Right.
square, and half moon.
And, I've never seen them.
Half moon. I guess one of them running around with it. So when you look at those, and then of course, they're identified sometimes on the schematic, but usually on the can.
Yeah.
Does anybody know what this is for?
It's for mounting a capacitor.
And why? It's an insulator. Thank you. That was what I was looking for. Yeah, you got the 2 here. I can't tell you how many times I've seen where you've got a lug here. And especially, they try to get them offset, but occasionally you'll get a piece of wire, the insulation will back off over the time. And you're in working on the radio, moving things around, and you run one of the wires where it is now bare. You'll cross it against one of these 4 posts that's grounded. Another thing I'll share with you is if you're working on an All-American 5 that has a circuit board in it, there will be places in the circuit board for these tabs. If you're working on one, you can't run the capacitors to one tab. Make sure you connect all the tabs, because the circuit board, some of them will run to this tab, another one to this one, third one to this
Seen
one.
that.
Get it all done, you get the caps between the center post and one of the grounds, but none of the other grounds are connected. So beware, if you've got one of these on a circuit board, make sure you get all the negative posts combined if you remove that capacitor and just put regular ones in. Ground needs to be comprehensive all the way around. Okay. One last bit of business I want to talk to you about while we're doing this. I'd like for each of you to look at the pamphlets that you've got. I'm looking for one that has 3 staples. All the rest of you were losers. You've got 3 staples?
Yeah.
Let's see. Prove it. All right, you're the winner of today's, and you get this. No, I'm just kidding. Some of you will run into these critters. Does anybody know what these are?
The
PC pack.
Multi-pack or a PC pack, or a number of other things ending with the word pack. What's in here?
Resistors and capacitors.
Yep, resistors and capacitors. And guess what?
Ceramic.
The ceramic capacitors, these things are usually good, and the resistors are always bad.
Yeah.
Okay, I'm not going to go into detail on how to address these, but if you have one of these and you're interested, give Mike or I a call. I think we both have our solutions for them, and they're identical. So you don't have to call both of us, but we can tell you how to deal with
Make your own.
Yeah.
Yeah, kind of have to make your own.
We kind of have.
All right, that's all I've got.
Any
Questions?
questions?
Anybody have more for the group this morning?
Very good.
All right, thank you. Your door prize this time is a set of All-American 5 food.
Oh, nice.
Okay, you guys, Rob isn't on the show, so we'll Rob.
Move on away.
Christian, you win your prize for this month. You get a shirt.
Right,
Yeah, good to see you.
And Mike wanted to. I don't even.
Oh, no, I don't want to win a second time. How did it end up back in there?
You'll have to find out one. So I made a decision. You didn't get- you didn't do this. You don't get a chance, you only get a chance.
We talked about safety. And you have I didn't. Basically, we talked about. Very
I didn't even know.
One's like,
It is second Saturday in April, right, and then down in Aurora, and, actually, Ray, John's very good guy. Oh, thanks. It's a lot of fun. Yeah.
Well, this is these giants. There isn't any.
No, these are super big.
Well,
No, I'm buying the sweet one. That was, XL. And with the motor.
okay. Is there an XL? 3XL, 4XL? We can have one. Shrink it.
Made out of
Giants.
Okay.
And then I never had, didn't have anyone get on the Zoom. Nobody got on the Zoom, not even Damon.
I'm here.
Where are those bumblebee hats?
Give me the lady in the back. I'm gonna turn them into jewelry.
Do what?
She's gonna turn them into jewelry. I would have brought them over, give them to you. You want the other one?
If they're the right sizes, that's the deal. She can, she might be turning the wrong ones.
These are, those are all new stock. I thought.
Yeah, but she might.
Yeah.
They might, there might be some of those in there.
Most people like I got rid of that wire would just disintegrate. And I've wired any of those. So it just has to be. Just want Yes, like it's always
Talking about my birds.
Yes.
Yeah. So if I did, that's not. No, I'm sorry, I'm not talking about.
don't fix it.
Then it's not a concern.
They skip all the sentence.
No.
They're just- Every idiot thinks they're.
That's the way I do it. I think it's in there.
I just went through it. It's just, yeah.
He says, no, that's. The goals aren't set. And I'm thinking to myself.
You know, I've never had one of those. You put a 600 light through it. I mean, it's like way over. Unless you were to have some enormous. The circuit breaker in the house. That's right. You're right. That's what would happen. The circuit breaker would pop. And I would bet that 630 volt DC capacitor would handle a heck of a lot more than 630 volt AC. Like, you know where the capacitors went that you had down? Do those come through? Okay. I just wanted to. All right.
Well, that's good.
Yeah. You actually know what they want now.
Yeah, it's in that box. Right there.
Oh, here. Oh.
No, you can't.
That's what I'm getting at. That's not.
Thank you.
Thank you. Where did my?
Right here.
Thank you for your confidence. That helps. I'm probably gonna get it. Okay. I'm already gonna tag you.
Yeah. Oh. Yeah.
There's a lot more that goes into it than just the freaking thing.
Oh, for sure. Yeah, there is a whole lot more that goes into it. That's good. Yeah, yeah. Oh. Yeah, well, that's, yeah. On those, you can do that. On some of the other ones, one of them goes out, and all of them, so then you don't know which one's bad unless you have an ohm meter.
I mean, really, but if you were.
Okay. Oh, nice. That's, I love it when people reproduce stuff like that.
I do.
You know, I don't have.
It's all. Yeah.